Okay, this is chapter 6.2, properties of rational exponents and radicals. Basically, this is no different than any other exponent rules you've ever dealt with. All right, and I'll scroll down to the rules here just a second. Ooh, escape. Yeah. Discard. Scroll down. All right, and these are your rules. All right, and they're no different than anything else you've ever dealt with. When you are multiplying, you add your exponents. So, if I've got 5 to the 1/2 times 5 to the 3/2, I simply add 1/2 and 3/2, and I get 5 squared, which is 25. So if I'm multiplying, I add the exponents. All right, same idea. If I'm dividing, which I don't know why they put it way down here. If you're dividing, you subtract the exponents. All right, you subtract those exponents. So in this case, it's 5/2 minus 1/2, which is again 2. The same idea. If you have an exponent to an exponent, you multiply. So m to the n, or in this case, 5/2 squared. Well, 5/2 squared is 5/2 times 2, which is 5. Okay, 5/2 times 2 is 10/2. That sort of thing. The power product. Basically, this right here is essentially distributing. We're going to distribute. Those both have 1, so we'll distribute whatever that is to those. So it's m times 1, m times 1. Distribute that out. So like over here, these both have 1s. So we can distribute that 1/2 to both of them. And if you can reduce, you reduce. All right. Now, I will say this. The biggest mistake I see on this is if you see things like this. Let's say 10 times xy squared to the third. Students will distribute it to the 2 and to the x, but it's so easy to forget that that 10 has an exponent 2. You have to distribute it to that 10. So it is a 10 to the third, which is 1,000, x to the third, y to the sixth. All right? A few other things. And the distributing thing also works if it's a fraction. So down at the very bottom, where we got the fraction, these both have 1s, and you simply distribute it to both of those. All right? The two other rules are just things you got to know. First of all, a negative exponent means I'm on the wrong side of the fraction. If I'm top, I belong on bottom. Likewise, if I'm on bottom, so if I've got 1 over a to the negative 1, what that really means is I belong on top. I belong as an a equals a. Okay, that's all that means. And you see that right here. This 36 to the negative 1/2. The negative simply means shove it down there, and then 36 to the 1/2 is the square root of 36, which is 6. The last rule, which you just have to know, a to the 0 is not 0. Anything to the 0 is 1. Anything to the 0 is 1. So it can be the craziest equation you ever saw in your life, going, oh my lord, how do I even think of that? If that's to the 0, the answer is 1. Okay? So from here, we're going to go through a few examples real quick, and we'll keep on moving. All right, number 1 on the next page. Basically what we're going to do is we're simply going to distribute that exponent. All right? So it's negative 1/3 times 3. It is this exponent times those exponents, which 1/3 times 3 is simply 1. But it's a negative, so we've got 2 to the negative 1 negative times 3 to the negative 1. Okay? Which, from here, we can just think, oh, well, negative simply means I belong on the bottom side of the fraction, so that's 1 over 2 times 1 over 3. And 2 times 3 is 6. Okay? Number 2, same idea. Negative exponent means I'm on the wrong side of the fraction, so instead of being below, it belongs on top. So we'll start off by writing it that way. 10 times 10 to the 4/5. Because we moved it up, it is no longer negative. Once it's on the right side of the fraction, we no longer have to make it negative. Just like on number 1, when we moved it down, it now has a positive exponent. All right? If it's where it's supposed to be, the exponent is positive. Anyways, back to number 2. We're multiplying these, and we're multiplying the same base. Since they're both bases, we add the exponents. So 1 times 4/5, 1 plus 4/5, I'm sorry, is 9/5. Okay? And we could multiply that whole thing out, but this is actually the simplest way to do it right here. It's actually, I think, the 100,000. 1, 2, 3, 4. Yeah, that would be 100,000. Because the 9th power, no, actually it wouldn't be 100,000. It wouldn't, but that's the most reduced way you can have it. Number 3. Number 3, you notice how we talked about we can take this and distribute it to the inside? We can multiply that 1/6 to the exponents on the inside. Well, that also works the other way. If I have the same exponent, I can also multiply it outwards. It's kind of like saying, if I've got, we did stuff like 2x plus 4, and we divide that out to 2 to the x plus 2. All right, I could pull the 2 out, or I could put the 2 back in, either way. So the same thing here. This is actually easier if I multiply and put it on the outside. 5 times 1/6 is 5/6. So far you've got 52, stop it, 52 over 4 to the 5/6. And the reason I say it's easier to do this way is because we can divide 52 by 4. 52 divided by 4 is 13 to the 5/6. And the reason we're going to leave that alone, 13's prime. I could raise it to the 5th power, but I can never take the 6th root. So we're going to leave it like that. That's just about as simply as we can write it. Now, number 4. Number 4 is a bit of a pain. All right, 4 is to stretch you. There's a lot of things going on here. First of all, what I'm going to do is I'm going to get a common base on the top. So, and here's how I think through that. 27 is 3 cubed. But then that's raised to the 2/3, right? This is that. Okay, that's the first thing I want you to understand. And whenever you have an exponent to an exponent, you simply multiply those exponents. You would multiply these two together. So that equals 3 to the 6/3. 6 divided by 3 is 2, so that's 3 squared. So I'm going to go ahead and write that as 3 to the 1/3 times, that's a horrible 1/3. That is a 3, believe it or not, times 3 squared divided by 8 to the 4/3. Cool? That's the first thing I did. And the reason I did it is so I could get the same base on top. Now I'm going to do 2 things at once. That base on top, since we have the same base, I can add those exponents. Remember, same base means we can add the exponents. So 1/3 plus 2 is actually, so 1/3 plus 2 is 7/3. Don't believe me? Break out your calculator. So that's 7/3. All right. And divided by, the other thing I'm going to do is that 8. Well, let's do it in the next step. 8 and the 4/3. Okay. The last thing I'm going to do is this 8 in the bottom, this one down here. All right. Remember, for all fractional exponents, the top number is the power. The bottom number is the root. So this is the 3rd root of 8, which the 3rd root of 8 is 2. So I can, let's write this again, equals 3 to the 7/3. All right. The 3rd root of 8 is 2. So this is 2 to the 4th. Which 2 to the 4th is 16. So the easiest way to write this is 3 to the 7/3 divided by 16. It really is the easiest way to write that. All right, and that's how we're going to leave it. Because I can't take the third root. I can't take the third root of 3. I could raise 3 to the 7th power, but that's freakishly huge. And so we're just going to leave it like that. Okay? And so, but that really is just to kind of get you through how do these exponent rules work. If I were you, I would go back through those and try these on your own to see if you can reach the same result, or do them over until you can. All right. I'm also going to go ahead and do number 5 real fast because 5 is quick. But that's what's going on with 1 through 4. So let me pause real fast. Number 5. Find the simplified expressions for the perimeter and area of the given figure. Well, okay, they want the perimeter and they want the area. Well, remember, perimeter of a square is 4 times the side. So it's 4 times one of the sides. Okay. The area of a square, it's base times height, right? But the base and the height are the same. So it's this one of the sides squared, because it's that if the side of a square is 4, it's 4 times 4. All right, to get 16. So here we go. Let's just knock this out. For your perimeter, perimeter equals 4 times one of the sides, 10x to the 1/4. And the only thing we can do here is simply distribute. So P equals 40x to the 1/4. Okay. Boom. This one is a little bit different. So we have to do the area is that side squared, 10x to the 1/4 squared. And we can distribute that 2 on the inside. Go ahead and pause and see if you can finish it out. Okay? Pause it and see if you can finish this one out. Okay, hopefully you did that. But here we go. So A equals, if I distribute that 2, remember, there's a 1 right there. If you forgot that 1, go back and fix it. But here we go. So this becomes 10 squared and x to the 2/4, which we can reduce that down or simplify it, 100x to the 1/2. And that would be your area. Okay? Good luck.